Hello my dear students, welcome back to Learn Physics. In today's topic, we are going to discuss about the diffraction. Diffraction is the bending of light ray around the corners of an obstacle. Okay, so when light ray bends into so it will be penetrating to the geometrical shadow. We can consider that the light ray is passing through it, in that an obstacle is there. Okay, what will happen? The light ray will be bending near the obstacle. At the obstacle position, it will be bending, or the light ray will be penetrating into the geometrical shadow. So it will be penetrating into the geometrical shadow. This is the geometrical shadow. So it will be coming to that position. That is called diffraction. So a ray of light is incidentally, so only a single slit is there, so light will be penetrating into this geometrical shadow position. So this is the obstacle. So when light is coming here and it will be passing through this and it will be penetrating into the sides of geometrical shadow, this phenomenon is called as diffraction. Okay, so this is also another example for this phenomena which we can explain only with the help of this wave optics. Okay, so here if I am considering, so a diffraction experiment, same like interference we can do, but here we doesn't require two slits. We require only a single slit for getting the diffraction pattern. So here a source of light is here. Suppose a source of light is here. I am taking all the lights. So all the secondary wavelets are superposing over here. Here we are considering secondary wavelets superposing, and will be getting what will happen here is this screen which we are getting. Again we are using a convex lens over here, and it will be penetrating, and we will be getting the fringes at this side. Okay, here also we will be getting alternate dark and bright fringes will be getting. Okay, so instead of telling dark and bright, we will say it as maxima and minima position. Maxima and minima. What is this maxima? Light intensity is maximum. Minima means light intensity is minimum. Minimum means complete darkness it will be. But at the center position we will be getting the maximum brightness, and when we are moving to the next nearby bright fringes, so then we can say the intensity is getting reduced. Intensity of those light rays will be in maxima position itself. So when we are moving away from this center position, we can observe that the light, almost dark and bright fringes will be mixing. We can't differentiate that much between the dark and bright fringes. Like that it will be. Okay. So this diffraction patterns also won't be always equal. Okay, it won't be equal at all, but we can in interference we have a chance for getting the equal interference fringe width will be same, right? So here, but in this case the distance between the two bright fringes or two maxima positions or minima positions we can't predict. It will be always unequal. Okay, and here the intensity also, when we learned about the interference, we learned that it is of a same intensity. Maxima means same intensity it has, right? Intensity is same. But in the case of diffraction pattern, when we are considering the diffraction, center will be at the maximum position, but both the sides it will be decreasing. Okay, intensity will be decreasing at the side as we move as it is moving far away from the center fringe. Center fringe we will be getting a maximum value, but when we are moving away from that, the intensity will be decreasing. Okay, and here what will be the path difference? So when I am considering a wave here, so what will be the path difference at that position? So how we can find out the path difference? A sin theta, we will get it as n lambda. See here, these are the positions which I am considering, and these are of angle theta. So A sin theta, if I am considering, it is equal to our path difference, A sin theta. So since this is theta, here we can consider this as theta, and here it will be Sin theta while we are considering a sin theta equals n lambda. If a sin theta is considered as the path difference. Okay, here what is the difference between the path? So a sin theta equals n lambda. If it is equal to n lambda, it will be the position of minima, and a sin theta equals n plus half into lambda. There you can say it will be the position of maxima. Okay, clear children? So the values will be plus or minus 1, 2, 3, etc. Okay, this will be the position of maxima and minima. Clear? So in the indifference we learned it as conditions as path difference n lambda, we learned it for maxima, right? But here a sin theta equals n lambda, this is the position of minima, and a sin theta equals n plus half into lambda as for the position of maxima. So if I am considering the first maxima position, see here n is equal to 1, we will be getting a sin theta equals 3 by 2 lambda. Right, or we can write it as which is a sin theta nearly equal to a theta, that is equal to 3 lambda by 2. So I am considering the wave into 3 sides, 3 lambda by 2, lambda by 2, lambda by 2. First 2 lambda by 2 will be cancelling each other, and we will be getting the only lambda by 2 over here. The rest of the position while superposing each other, first 2 lambda by 2 will be cancelling, and only the third one will be remaining. That is the reason the next ray will be having this intensity is reducing. Then if I am considering the next bigger one, next maxima line, while I am considering, it will be 5 lambda by 2. So here first 4 will be cancelling, only the rest of the lambda by 2 only will be existing, that is of minimum intensity. So intensity will be reducing as it moves upward. Okay, from the center we will be getting the maximum wavelength. Okay, or maximum intensity, not wavelength, maximum intensity. Now we are going to consider about what will be the distance. See this distance from the center maximum. How can we find out? See here this distance, if I am considering as x, and this is theta, right? So this is theta, and this distance is x from the center. At one point I am considering it as x. Then I can write it as here sin theta equals x divided by this distance is d, distance, or f I can consider for the slit, or I can distance between the slit and the screen, if I am considering it as capital D, sin theta will be equal to x by d, or we can write theta equals x by d. Okay, this is the theta. And so angular separation when we are considering, see this one theta is x by d, then what will be this angular separation between these 2 points? It will be 2x by d. Or x, if I am considering, what will be the value of x? For that we got it as a sin theta. If I am considering the position of minima, a sin theta equals n lambda. Here a sin theta equals n lambda, and a sin theta equals x by d. Okay, so I can equate this a sin theta, that is lambda for the first one, lambda by a equals, sin theta is lambda by a, so here sin theta equals x by d. So for the first minima, a is sin theta equals n lambda by a, lambda by a, if n equals 1. Okay, so here we are getting it as sin theta equals lambda by a, sin theta equals x by d. So we can substitute x by d, lambda x by d equals lambda by a. Therefore, we will get here x equals lambda capital D divided by a. So that width will be 2x will be equal to 2 lambda capital D divided by a. That's also important. So for the minima position, a sin theta equals n lambda. For first minimum, a sin theta equals lambda. Therefore, sin theta equals lambda by a. And here from this, we are getting it as from here, this diagram, we will get sin theta equals x by d. So we can equate x by d equals lambda by a. Therefore, x we are getting it as lambda capital D divided by a. 2x equals 2 lambda divided by d divided by a. So here thus conditions are important, what is meant by diffraction and how we are obtaining why the intensity of the waves are reducing as we move away from the center maximum. Okay, then next is the positions. So what are the conditions for maxima and minima? Maxima condition is a sin theta equals n plus half into lambda. Minima condition is a sin theta equals n lambda. Now next is what is the angular separation between the slits. Angular separation we got it as x by d, and here the value distance is x lambda distance of separation between the waves from the central maximum. X is equal to lambda capital D divided by A. Okay, so these conditions you should by heart about the diffraction. Clear? So we will do now some numericals based on this. So here all the formulas I wrote over here. The minima position is a sin theta equals n lambda. Maxima position is a sin theta equals n plus half into lambda. So here and all you should consider n is equal to 1, 2, 3 etc. Okay, width of central maxima 2x. Already we got the value of x, right? So here when we were drawing the diagram, see this is the position of maxima, then minima, then maxima, like that it will be going, right? So these are the distance from the center, position, first dark point, first from the center position, first minima point to the other side. So the distance between these two will be, the total distance between these two will be the position of the width of central maxima. So that we are getting 2x as 2 lambda capital D divided by A. Okay, so the first question is, a parallel beam of light of 600 nanometer falls on a narrow slit and resulting diffraction pattern is observed on a screen 1.2 meter away. It is observed that first minimum is at a distance of 3 millimeter from the center of the screen. Calculate the width of the slit. Okay, we should find out the width of the slit, that is A we need to find out. A is the width of the slit and lambda is the wavelength, and this 2x and all I already told you, right? Capital D is the distance from the slit to the screen. Here parallel beam of light of 600 nanometer falls on a narrow slit. So wavelength is given as 600 nanometer. 600 into 10 to the power minus 9 meter. Then as falls on a narrow slit and the resulting diffraction pattern is observed on a screen 1.2 meter away. That means capital D is given as 1.2 meter. It is observed that first minimum is at a distance of 3 millimeter from the center of the screen. So first minima is position is when n is equal to 1. At that distance x is given as what is that? 3 millimeter. 3 into 10 to the power minus 3 meter. We should find out, calculate the width of the slit. A we need to find out. Capital D, lambda, capital D, n, x. So which formula we can use for finding out the, what is that, A? 2x equals to, yes, 2x equals 2 lambda capital D divided by A, or x is equal to lambda capital D divided by A. Therefore, A equals lambda capital D divided by x. So 600 into 10 to the power minus 9 into 1.2 divided by 3 into 10 to the power minus 3. So here 200. So 240 into 10 to the power minus 6, or we can write it as 0.24 millimeter. Okay, this will be the value of the slit. Then that much small slit if we have, then only the diffraction pattern will be clearly visible. Clear? Next question. Two spectral lines of sodium D1 and D2 have wavelength of approximately 5890 angstrom and 5896 angstrom. A sodium lamp sends incident plane wave on a slit of width 2 micrometer. A screen is located 2 meter from the slit. Find the spacing between first maxima of 2 sodium lines as measured on the screen. So what should we find out? Here we have 2 spectral lines of sodium is given. The different wavelengths are lambda 1 is given as 5890 angstrom 10 to the power minus 10 meter, and lambda 2 equals 5896. 5896 into 10 to the power minus 10 meter. Clear? Then a sodium lamp sends incident plane wave onto a slit of width 2 micrometer. So A is same for both. 2 into 10 to the power minus 6 meter micro. Then a screen is located 2 meter from the slit. Screen is located 2 meter from the slit. Now find the spacing between first maxima of 2 sodium lines as measured on the screen. We should find out the spacing between this first maxima position, between first maxima of 2 sodium lines. How we can find out the first secondary maxima? So central fringe, it will be maximum. Next we can find out the first maxima. First maxima, this is the first position of secondary maxima. First secondary maxima, n is equal to 1, 2, 3, etc. So position of first secondary maxima for the secondary maxima. Central fringe will be of bride fringe. Then first secondary maxima, second secondary maxima, like that it will go. So central fringe will be a bride fringe, which is maxima, and this one is for the secondary maximas. Okay, first secondary maxima, n is equal to 1. Okay, therefore we can write it as, see here, n plus half into lambda. So 3 lambda by 2. 3 lambda by 2 equals a theta. This a theta we already got it as a here. Are you remembering? You are remembering, right? Here this is this difference we got it as here. This is a and this is x and this is d. Then what will be theta? Theta equals x by d. Therefore, we can write it as x equals 3 lambda capital D divided by 2. This is the value of x. So now we can find out the values of x1. x1 is equal to 3 lambda 1 capital D divided by 2, and so sorry, I forgot about x. A. What is a here? Here. X is equal to 3 lambda capital D divided by 2a here, and x2 equals 3 lambda 2 capital D divided by 2a. We need to find out the spacing between the first secondary first secondary maxima of this 2 wavelengths. So here x1 minus x2, we will be getting it as x2 minus x1 equals 3 capital D divided by 2a into lambda 2 minus lambda 1. Okay, so here lambda 2 minus lambda 1 is 6. 3 into 2 divided by 2 into 2 into 10 to the power minus 6 into here it is 6 into 10 to the power minus 10. Here equal to 9 into 10 to the power minus 4 meter. Okay, clear children? This is how we will be solving these kind of questions. Okay, so this is the important topic, this interference and diffraction. The rest of the topics, that is polarization and all, it's not there for resolving power also. It's not there for this what is that, in your reduced syllabus, those portions and all deleted. Okay, that is coming under deleted portion. Resolving power of a telescope, microscope and polarization. So with this, this wave optics chapter is getting over. So I hope it is clear for you, and in the next video, we will be starting dual nature of matter and radiation. Okay, so if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.